Hello everyone, welcome yet again to another edition. Today we're looking at hypothesis testing. Hypothesis testing, we can say, is a formal procedure for investigating ideas about the world using statistics. Before now, hypothesis testing was mainly used by scientists to test specific predictions called hypotheses that arise from theories. But today we can see from the social sciences everywhere we test hypotheses now. So hypothesis testing starts with a statement describing some aspect of a population, given a hypothesis to be tested. So what are the steps that we can take in testing a hypothesis? 1. We define a simple, precise statement about a population, and that is what we call the hypothesis. So we have the null hypothesis, and we have the alternative hypothesis. So after developing your initial research hypothesis, that is the prediction that you want to investigate, it is important to restate it as a null and alternative hypothesis so that you can test it mathematically. The alternative hypothesis is usually your initial hypothesis that predicts a relationship between the variables. So your null, on the other hand, is a prediction of no relationship between the variables you are interested in. So the second aspect is take a sample from the population, collect data in a way designed to test the hypothesis. So that is the second one. If you want to test the hypothesis, you just don't look at the situation and start guessing. No, you collect data from the sample from where you want to test the hypothesis. Then and this data collection must be done using a proper way, let's say a probability sample, so that you can infer back to the population. For a statistical test to be valid, it is important to perform sampling and collect data in a way that is designed to test your hypothesis. So if your data are not representative, then you cannot make statistical inferences about the population you are interested in. The third step is to perform an appropriate statistical test. We're talking about hypothesis testing, and the first thing that comes to mind is those that we have been using more frequently. Let's say for t-test, analysis of variance, chi-square. So these ones come to your mind frequently because they are frequently used and we see them often in books. But there are other statistical tests that we can do besides these three that I just mentioned. So let's say there are a variety of statistical tests, yes, available, but they are all based on comparison of the within group variance. That is how spread out the data is within a category versus the between group variance. What is the between group variance? That is how different the categories are from one another. So if the between group variance is large enough that there is little or no overlap between the groups, then your statistical test will reflect that by showing a low p-value. This simply means that it is unlikely that the differences between these groups come about by chance. Alternatively, if there is a high within group variance and a low between group variance, then your statistical test will reflect that with a high p-value. So this in essence implies that it is likely that any differences you measure between the groups is due to chance. So your choice of statistical test will be based on the type of data that you will collect. So step number 3, you decide whether or not to reject the null hypothesis. Based on the outcome of your statistical test, you will have to decide whether to reject or fail to reject your null hypothesis. So in most cases, you will use a p-value generated by your statistical test in your computer to guide your decisions. In other places too, you will have to compare a calculated value with a formal statistical table to make your decision. So whichever one it is, we'll see how we can read the table or use the p-value in determining making our decision in the long run. The last but not the least is to present your results. So of course, when you finish with your analysis, you will have to do a presentation. The results of your hypothesis testing will be presented in the results and discussion sections of your manuscript. Let's take an example. A manufacturer of salad dressing uses machines to dispense liquid ingredients into bottles that move along a filling line. The machine that dispenses the salad dressing is working properly. When 8 grams of salad dressing are dispensed, think I missed that. Suppose that the average amount dispensed in a particular sample of 35 bottles is 7.91 with a variance of 0.03. Is there evidence that the machine should be stopped and production wait for repairs? That is question number 1. The lost production from a shutdown is potentially so great that management feels that the level of significance in the analysis should be 99%. Okay, so we are answering one question. The question of whether or not to stop and repairs take place or production can go on. Let's pick out our parameters from the question. 1, we have the sample size, which is n, 35. Then we have our sample mean, 7.91. Then we have our standard deviation. Standard deviation is square root of the variance, and our variance was given as 0.03. So we have square root of 0.03, which is equal to 0.173. And then at what alpha level? So we're given a confidence interval of 99%. So take that from 100 and we are left with just 1%. So 1% is equivalent to saying 0.01. Next, we state our hypothesis. The null hypothesis is that we don't need an equal sign here. Mu is equals to 8 grams. And then the alternative, it's saying mu is not equals to 8 grams. So this is a two-tailed test. Let's have our Z relation, x minus mu, x bar minus the mu, all over s divided by square root of n, where s is our standard deviation, n is our sample size, x bar is our mean, mu is the population mean. So this is equals to, we have the sample mean to be 7.91 minus the population mean, 8 grams, I'll put the grams there. Then our standard deviation we just calculated that to be 0.173 divided by square root of 35. 35 is our sample size. So do the calculation and we have z equals to negative 0.09 all over 0.0292, and this will give us negative 3.08. Now, as we indicated in other videos, this is a negative value and we hardly see the positive normal distribution table flying around. So what we can do is to actually read from the positive table and see how we can convert that to a negative table value. So to read a value of negative 3.08, we'd say this is equivalent to 1 minus the reading of 3.08, where this is gotten from the positive table. So if we read the same value, 3.08 from the positive table, and subtract it from 1, it is equivalent to reading the negative 3.08 in the negative table. So we don't have anything to worry about. So reading 3.08 from the table would give us 0.99856. So subtract that from 1, then we have 0.00144. This is the probability. Now, let's make our decision. So we have our p-value to be equals to 0.00144, and we're given an alpha value 0.01. We now have to make our decision. So we're going to say, since the p-value, that is 0.00144, is less than the alpha value, the error margin that we stated for ourselves, 0.01, then we have enough statistical evidence not to accept the null hypothesis. So what do we conclude? And conclude that the machine is broken and need to be repaired. So this is the conclusion from our analysis. Let's take a second example. The procurement officer who is doing a feasibility study on the total cost of football pitch knows that the cost of constructing a football field is approximately normal with standard deviation 60 Ghana cedis. A random sample of 12 contractors who is bidding for the project has a mean cost of 3250 Ghana cedis. So the question is to test the hypothesis that the average cost is 3500 using an alpha value of 0.01. So the first thing we do is to pick out what we need, the information in terms of the parameters, the sample size if there is any, sample mean if there is any, population mean if there is any, standard deviation if there is any. So from here we have our sample to be 12 contractors. Then our X bar, what will be our X bar? 3250. And what is our population mean? That will be 3500. So we have our standard deviation. What will be the standard deviation? That is 60 Ghana cedis. The null hypothesis is that mu is equals to 3500, and our alternative is that it's not equals to 3500. Z value, let's denote this by Z naught or Z calculated, is equals to our X bar minus mu all over S divided by square root of n, and this would be equals to, we just fix in the values, 3250 minus 3500 all over 60 divided by square root of 12. So we put this in the calculator and we end up with negative 14.43. Now we want to get the Z value in the table to compare with this. So let's have a reading of our Z, and we know this is equals to 1 minus 0.005. It's a two-tailed test, and our alpha value is equal to 0.01. So if we divide this by 2, we get the 0.005. So it will mean that we have this here will be 0.005, and then the other side will be 0.005. So that is why we're subtracting by 0.005. So we have this equals to 1 minus 0.005, and that will give us 0.995. Alright, let's read this in the table. Our z is equals to negative 2.58 because it falls within the negative side of the table. So we'll have to negate this value. So we compare this value here with what we have calculated, which was z0 is equals to negative 14.43. So we compare these two and make our decision. We are going to reject, that's our decision, reject the null hypothesis if what we have calculated is greater than what we read in the table. So looking at the two values, we can now state that since negative 14.43 is less than negative 2.58, then we cannot reject the null hypothesis and conclude that the average cost of the project is significantly different from 3,500 Ghana cedis at 1% level of significance. So this is our conclusion based on the analysis we've done to this question. Example number 3. A light bulb manufacturer guarantees that the mean life of a certain type of light bulb is at least 750 hours. A random sample of 36 light bulbs has a mean life of 745 hours with a standard deviation of 60 hours. Do you have enough evidence to reject the manufacturer's claim? Use an alpha value equals to 0.05. Again, let's state our hypothesis. Mean greater than or equals to 750. From the question, the first line is, the first sentence reads, a light bulb manufacturer guarantees. So this is the claim from the manufacturer that the mean life of a certain type of light bulb is at least means more than 750 or more. So that is why we have in greater or equals to 750. So it will mean that our null hypothesis will be the other half of the number line, which is less than 750 at 0.05. So we have our standard deviation from the question equals to 60, and our sample size is 36. Let's take our Z formula. X bar minus mu all over S over square root of n, and we put our values inside. What is X bar? X bar from the question is 745. So you have 745 minus 750 all over 60 divided by square root of 36. And this will give us negative 0.50. What do we want to do with this? We want to read this in the table. So we have probability of Z equals to negative 0.50. Actually, we should have that. Then we have this to be 1 minus the probability of reading it from the table, the positive table, 50. So this will give us 0.3085. How do we conclude? This is greater, 0.3 is greater than 0.05. So we cannot reject the null hypothesis. And why can't we do that? Because our p-value is greater than alpha value that we set for ourselves. So we conclude by saying that there is not enough statistical evidence to reject the manufacturer's claim at the 5% level of significance. So what it simply means is that the manufacturer is right to say that the average mean life of the bulbs that is manufacturing is at least 750 hours.